Until now, we have only discussed about what Python is used for and how the projects look and packages behave, right? Today, we will be starting the actual core Python. And before we learn about Python or any programming language in general, the first thing every developer should do is to know the different types of data that language allows us to represent. When I meant data, let's say there is a programming language called X, and that programming language X does not support numbers. It sounds awkward, right? What if the language doesn't support numbers? In such case, you cannot represent any numerical data or make any calculations, any expressions on it. So, while starting out any language, you first need to know the different types of data the language allows us to represent. In case of Python, we will learn about the now there are around 10 basic data types that the Python represents, and we will just go over all of them briefly. Good. And you might even think, why should we even represent data? Because even a human or a computer or a programming language, while making a decision, they make decisions based on data, right? For example, take a look at my screen. Here, let's say if John had 100 rupees and he wanted to go for shopping, his this and his shopping this action, his amount and his shopping actions can be represented as follows. Let's say money is equal to 100. I'm just telling that John has a money of 100 rupees and is mall open. So if John wants to buy something, so the first thing he needs to check is whether the mall is open or not, right? Here I am just representing that mall open is equal to true, which means the mall is open. Then he wants to go for a dining. If he wants to go for a dining, his thought process will be something like this, right? I have 100 rupees. I went to the mall and purchased something. I want to go to the restaurant. But in order for me to visit the restaurant, I need to know whether it is open or not, right? And the data that represents whether the restaurant is open or not is like this. Here is restaurant open is equal to false. If this is confusing, you can ignore it. I am just showing you that any programming language needs to represent data, and the data is then used in our decision making process, which is the core this which is why computers and program languages exist in the first place. Good. Now let's go over the most let's go over the different types of data in Python. In Python, data can be classified into two types, data types and data structures. And the data types are the most basic form of data. And when I mean that, there is nothing smaller than this. And data structures are containers. Let me give you a quick example. Let's say you have few files on your system. Files are analogous to data. Now, let's say the files are related, you have your Aadhaar card, PAN card, and stuff, every government document related. If they grow too much, what will you do? You will create a folder called government documents and then put all your files into that folder. Like here, the files are equivalent to data types and the folders are equivalent to data structures. And now the Python has 6 different data types. Integers, the name itself gives it away. Any number without a decimal point, positive, negative, or 0, is called an integer in Python. And they can be written directly using your keyboard. Let me open this. Split and move run. See, here I just opened 2 notebooks, one notebook on my left side for explaining data types and some empty notebook on my right side. Now here I am just writing how an integer looks. You can just See, this is an integer, and even this is an integer. Any number without a decimal point is called an integer, and a float is nothing but any number with a decimal point. See here, these are integers, right? I just placed a decimal point or full stop here, and these will become floats. These integers and floats together helps us represent numeric data or any numbers. These are generally used to store names, account balances, age, expenses, and stuff. And there is also a complex data type. If you are familiar with if you still remember your math from 11th and 12th standard, a complex number, you might be familiar with complex, but we won't be using this complex much. You can basically you can forget this. It never existed in Python. The next thing, the string. String is the most useful one out of everything because the strings, the user names and the user comments, the user messages and summaries are basically represented as strings. String is nothing but a text. Any text in Python is called a string, but there is a strict rule. The text should always be enclosed in single quotes or double quotes. If you see on my right side, here, hello world. Both are both are strings. And string can contain any number of characters. This can go to infinity too. Now, okay. And the final one is Boolean. Boolean is used to represent true or false. Let's say uh, there is a question. Uh, is John active? Let's say we are running an application, a web app, and we are tracking whether the John is actively using our app or not. If I wanted to store information about John, like whether he is active or not, I have to store it in true or false, right? I can't store that is John active is equal to 22. The word active means either true or false, and I cannot use numbers or above strings to represent this state, and thus the booleans exist. Booleans are There are only two booleans. Unlike integers and floats, there you can create infinite number of combinations for integers, floats, and string. But for boolean data type, there are only two values: true and a false. That's it. And finally, none. None is also an inbuilt data type. This just represents that data doesn't exist. That's it. Let's say if what is your name and the user didn't fill the name part and tried to submit something. In that case, what should we store in our database or in our file? In such cases, what we store is none. And this allows us, the developers or the one who is working with the data or stored data, that this user didn't enter his username. So this is set to none. That's it. Now, is data type clear? Is there anyone who didn't understand any of the data types? Good. Now, let's come to data structures. Like I told, data types are files and data structures are folders. Folders to represent related files into it, right? What if I wanted to represent, let's say, a student from college, and the student has different types of data, right? If I want to represent a student, I need to know I need to know his name. I need to know his age. I need to know his college name. I need to know his which semester he is currently in, and stuff. See, just to represent a single student, we need to capture 5 different types of data types. And if I started to do this will get annoying pretty quickly. 434. We need some construct to group this data together. And that's where data types come in, data structures come in. There are primarily 4 data structures in Python. You should remember their names. List tuple, dictionary, and set. Just like the name suggests, list is nothing but a list of elements. Here I am creating a list. List is generally created by solid brackets, then writing down your data. That's it. Here I am writing his name, John, and I am trying to write his age somewhere around 20, okay, college, right? 21 or something. Now I am trying to write his semester one, and let's say passed or not. Let's say true. See, here I am just using a single folder or a single data structure to represent the entire information about a student. And this way, you can use a list to represent any any entity. The lists are created by created using solid brackets, and inside you need to write the data type separated by commas. That's it. And if you are wondering, list can store any type of any data type and any other data structure too. Here I just wrote that this list is only storing John, which is a string, and 21, which is an integer, and semester one is also a string, and true is a boolean, right? I can even store his address, something like this. Um, let's read. See, this list is storing John's name, John's age, John's semester, whether John passed this semester or not, and then storing another list inside it. That list is representing his address. Just remember, list is an list of elements, and how you create it is using a solid bracket separated by value should be separated by commas. List can store anything, and tuple is list's brother. The only difference is lists are created using solid brackets, right? But tuples are created using circle brackets, parentheses, and every other feature is identical to list. Then you may ask, why should we even use a tuple when it is so similar to list, right? The only difference between a list and a tuple is how it is created, the parentheses and solid circle brackets. And the second one is once a tuple is created, this tuple cannot be modified again. In the later, I created a tuple to represent the student information, right? But if in the later stages, if I wanted to drop this value, like whether he passed or not from the list, I cannot do it. I cannot do it from the tuple, but I can do it from the list. Tuples and lists are exactly equal, except tuples are immutable. Immutable meaning that they once they are created, they cannot be altered. If you are having trouble understanding this, we will go detailed. We will go over this immutability and the lists and tuples detailed in the later sections. Just hear me out, and if you don't understand, ignore it. And then finally, sets. You can skip the sets. You won't be needing, since you are aiming to be a data engineer. You can basically ignore it. Dictionaries. The problem with list and tuple is the information stored in the list is sequential, right? We should write one after the other. Let's say I created a list or tuple, but I forgot which value is where. See, I scrolled to the bottom, but I don't know which value is stored at which position. Then in such cases, how should I retrieve the data? If you don't know where you stored the data inside a list, you cannot retrieve the data from a list. But in case of a dictionary is created using parentheses, something like this. What is the name? John. Let me ask for what is your age? 22. Semester 4. Pass. See, dictionary is an key value pair, set of key value pairs. Key means the tag we give to This is the actual value or the actual data we store. And this is the key. Now, one on the left side is the key. In order for me to retrieve the name, I have to use the keyword called name. Just like you store files on your computer, right? If you want to retrieve a file, you generally need its path, right? Similarly, you can store data as values in the dictionary, but you need to remember the keys in order to retrieve that data back. But in case of a list, you can write the data into a list, but if you want to retrieve, you need to know the position. Like I need the data at position 0, I need the data at position 2, something like that. But in case of dictionary, you need to remember the key. I need the data associated with the key called semester, something like that. Is the overview of data types and data structures clear? Is there anyone who didn't understand this? Good.
Tarun, we'll discuss every data structure again, right?
Yes, exactly.
Okay.
This is just an overview so that if I directly go to the data structure, you won't find it.
Yeah.
You first need to, this lecture, this entire class is about that why should we even represent data in Python or any other programming language, and different ways to represent data. Data types represent very small amounts of data, and data structures are like containers, folders to represent higher level objects. And I just gave you an overview, just to make you guys look and feel how a list looks and how a tuple looks and how a dictionary looks.
Yeah, okay.
Yeah. Now, up until in this lecture, I have been only writing data directly, right? Data into my cells. But here you won't see me reusing this data again, because we can't reuse any data type or data structure unless it is assigned to a variable. This is like writing all your logins in your some file, and you stored it somewhere, but you forgot it's where it is stored. Then does that file help you? No, right? The file exists, but you don't know where it is. You can neither see it or neither edit it and re-edit it. The same concept. Here, data types and data structures are the data, the files, but the variable, let's say, variables hold the location of the data, just like how the path of the file helps you retrieve the data. Variable helps us retrieve the data types and data structures. And variable can have any name, any character. We will discuss exactly which characters it can contain. There are certain small restrictions, but any name you can come up with will be sufficient. For now, let's say student details. Here I am creating a variable called student details, and I want to store the above created dictionary into this variable. See, what this means is I am telling Python that store this dictionary somewhere on my system, but store its address inside student details, so that even when I can't, let me run this. So that if I want to retrieve the data, all I need to do is see, and I can select it, since this is a dictionary. I can selectively retrieve. If I just wanted to retrieve his whether he passed or failed. No, I want to retrieve his age. You will learn this later in dictionary section, but I am just showing you that variable data by itself doesn't make any sense. Just like files that you don't know the path to. So we generally store them, attach them to a variable, and use the variable in order to use that data again and again. However, here there is a slight, very subtle distinction. Variable doesn't store the data. Variable points to the data. You might ask, why is this important? I will just remember that variable is storing the data. because this becomes a problem when, give me a minute. Screen. Can you see my screen?
Yes, sir.
Let's say I wrote give me a minute. Now let's say name is equal to John. Now let's say surname is equal to name. What I just did was I just stored John inside the variable called name, and then I created a new variable called surname and just made it equal to above variable. So you might think that since name is having John, surname is also will have John, right? Details. 1, 2, 3. Expenses is equal to details. Data type. Yes. Data structure. Good. Here, in both the left side and the right side, on the left side, I am just representing how data types behave. On the right side, I am just showing how data structures behave. Uh, when I meant data type, it can be either integer, float, or boolean or anything. On the right side, I'm just showing a list, but this behavior will remain the same for everything, every data structure like list, tuple, dictionary, and set too. Here, if you see the first line in the both sections is just storing a data in a variable, right? And in the second line, in both the left and right side, I am just equating that variable to another variable. And now you might think that John is stored twice on your system, and name is pointing to John one, and surname is also pointing to a different John. Similarly for details too. Details will point to 1, 2, 3, and expenses also points to 1, 2, 3. They are different. They are stored differently on your system, but they look identical. We can have that, right? I mean, I can store John twice on my system. Like you can store a file twice on your system. Similarly, you may assume this is the case that both name is pointing to a different zone and surname is also pointing to a different zone. Details is pointing to a different list, and then expenses is pointing to a different list. But this is entirely wrong. Like I told, variable, this might be true when the variable itself holds the data. If the name itself holds John, then your surname must also hold the name John. They might have been different. But I told you, variables will only hold the address. So when I made surname is equal to name, what name did was the variable name only passed the address to the surname, not the actual data. So the surname is also pointing to the same John. This didn't exist in the first place. The same happens to on the data types or data structures too. So when a variable is holding certain any data type or a data structure, and if you try to assign it to a new variable, it will only share its address. The new variable and the old variable also point to the same data. It will not share a copy. If you wanted to share a copy, then in such cases, you must have written something like this, name dot copy. Details dot copy. In such case, a new John would have been created, and this new variable would have pointed to that new John and not the old John. Is this thing clear that variables hold addresses and not the actual data? So this feature is causing this feature leads us to a situation where different variables can point to the same data on our system. Is this thing clear? I will explain in later section why this is even relevant to. Clear, right? Is there anyone who didn't understand this? Because this is the crux of object-oriented programming. If you understand this, there is nothing else in Python that can scare you.
Yeah, Tarun, one time, please.
Okay. What? Ask me a question. What did you not understand?
Yeah, I can just repeat. I was on call. Sorry, I missed that one. And just now I reconnected.
Okay, fine.
Sorry.
Fine. When you assign a data type or a data structure to a variable, the actual data type and data structure is stored on the system, and the address of that data type and data structure is given to the variable. Clear?
Yes.
Variables only store the addresses. So whenever you use a variable and try to pass its data to a new variable, like here, I am making that surname is equal to name, right? By default, as humans, we assume that name, the John is copied and the copy is given to surname. Like there is another John. You might think this is happening that the variable name is pointing to the John and the variable surname is pointing to a different John. John is stored twice on the system and name is pointing to one John and surname is pointing to different John. But actually what happens is, like I told, variables only hold addresses. So when surname is equal to name will only give the address to the surname and not the actual data, not the copy. So there is only one John, and the surname is also pointing to the same guy. Here, two different variables are pointing to the same data on the system. You might ask, why is this even relevant? Because let's say it's much more easier if I show it in code. You understood this, right? Just the
Yeah.
variable, just store addresses, and when you assign a variable to another variable, they pass on the address, and the new variable also points to the same data.
Same data. Yeah.
Good. If you want to pass the actual data, that is, if you don't want to pass the address and you want to pass an actual copy, in such cases, what you would do is name dot copy. The new
Okay.
variable is equal to old variable dot copy. That's it.
Yeah.
In such case, a copy will be created, stored on the system, and that copy's address will be given to the variable, new variable. Here.
Yeah.
Now, why should one else is sharing this screen? Off share. Good. Yes. Now, what happens if multiple variables point to the same data? Here. Now, this money, Bob's money, this money, see. Here is an example. Here, Alice underscore Alice shopping list is just a list, right? Here, Alice wanted to buy some tomatoes, rice, and potatoes. We represented it something like this. And Bob's shopping list is nothing but same as Alice's shopping list. You might assume that a copy is created and Bob list will also be identical to this. But actually, both Alice and Bob are pointing to the same list. So the problem comes when Bob already from his list, Bob purchased rice and tried to remove rice from his list. Let me run the code. Shopping list. You can ignore the code, just understand the concept. Now, there are two friends, Alice and Bob. Alice had a shopping list represented like this in our code, and then Bob tried to copy the Alice shopping list. Bob is let's say he doesn't have any free time, so he just copied the Alice shopping list, and this is how it is written in the code. And similarly, Alice had 1,000 rupees in his pocket, and just Bob also had the same money. We just assigned the Alice variable to Bob variable. Now I ran this cell. Now, but Bob, after copying Alice's list, went ahead and purchased rice. He purchased rice, so I need to remove rice from his list, right? This is just a code telling me that I should remove rice from Bob shopping list, remove rice because he purchased some rice. And his money, since he purchased rice cost 5 rupees, I think. And so I am just updating his money too. Bob money is nothing but his previous money minus 5 rupees for the rice. I am also running this code. Now, what do you think will happen when I try to print the Alice money and Alice shopping list and Bob's money and Bob's shopping list? You might think that Alice will have his 1,000 rupees in his pocket and all the shopping list because he hadn't done any shopping, all three items in his list. And Bob's money will be reduced since he purchased 5 rupees, and list will also contain one less item since he purchased the price, right? Let me print it. See, the money part is correct. Since Alice didn't spend any money, he had 1,000 rupees. Since Bob spent the money, he had 5 rupees, right? 5 rupees less in his pocket. But when you take a look at the Alice shopping list, Alice didn't buy rice. Alice didn't remove anything from his list. But you see, the rice is removed from Alice list too. So what's happening is Bob and Alice are pointing to the same data, and Bob tried to remove Bob removed an item from the data. So since Alice also looking at the same data, Alice list also got affected. You might ask, why is this important? Because whenever you are passing a variable to another value, make sure that do you want to affect the original data or do you want a copy of the data? If you wanted to affect the original data, this pattern is true. But if you didn't want to affect Alice list, then what we should have done is this. Just copy. Then I am running the same cells again. See, Alice list is safe. Bob didn't affect the Alice list, and Bob's list is true. This is what we call object referencing. Whenever a variable is passed to another variable, multiple variables can look at same data. So we should not modify the data. And if you try to modify the data using one variable, the other variable looking at the data will also get affected. Here, there is a problem. Since both Alice money and Bob money should also look at the same 1,000 rupees, right? So when I subtracted 5 rupees from Bob, you might think that why didn't the 5 rupees get subtracted from Alice pocket too? Did anyone get this doubt?
Yeah, it is pointing the same.
Yes, it is pointing to the same 1,000 rupees, right? Then why didn't when I even when I remove this copy, Alice money should also get subtracted by 5 rupees, right? It did not. It only affected the list and it did not affect the money.
Immutable.
Yeah, exactly. Data types are immutable. That means even when multiple variables point to the same data type, either an int, float, string, or boolean, you can pass them recklessly. You need not copy them. You can do anything with the data type, but it will not affect even when multiple variables are looking at the same data type, it will not break anything. But in case of data structures, most of the data structures are mutable, except list. There are 4 types of data structures: list, tuple, set, and a dictionary. Out of these 4, 3 are mutable. That means if a variable is storing a data structure, you should not pass it to another variable recklessly. You should be aware that should I pass an address, should I pass a reference? Address is also called a reference. Should I pass the reference or should I pass a copy? Should I create a copy and give the address to it or not? You should, this is what we call object referencing. The premise is that multiple variables can point to the same data. But if it is a data type, you can ignore this and nothing will go wrong. But if it is a data structure and that too list, set, or dictionary, this will be hard. You need to know what exactly you want to do. Clear, right? So with that, data difference between data types and data structures is complete. And you know why we need to use variables in the first place. We have to if you want to reuse this same data again and again, like file and file path. File is the actual data type and data structure. The file path is the variable in our programming sense. And then we have covered the object referencing concept. This concept will remain true across any object-oriented programming language. Since Python is a OOP language, we have covered it in here. This will remain true even in case of JavaScript. I think it's Java too. Java and C are also good languages. See here, data types complete, data structures is complete, and variables, why variables exist in the first place is complete. Object referencing is complete. Now, the naming rules for a variable. Here, I wrote names like this, right? Bob shopping list and not any other way, because there is a strict rule to write variable names. You cannot write anything. A variable name can contain capital A to Z, small a to Z, 0 to 9, and underscore. That's it. And a variable name cannot start with number. Just five rules. Capital A to Z, small a to Z, 0 to 9, underscore, and it cannot start with a number. Something like, it is very tempting to write first user, but this is second user. See, the ID is complaining that this is not a valid variable naming convention, because just like I told, a name can only start with cannot start with a number. If you wanted to do this, you should have done this user one and user two. Capital A, capital sorry, small a, small z, underscore, 0, 0. See. This name doesn't make any sense, but I'm just showing you that a variable name can contain capital A to small a, capital A to small z, sorry, small a to small z, capital A to capital Z, 0 to 9, and underscores, underscore. And it cannot start with a number. It can start with an alphabet, or it can even start with an underscore. Unfortunately, you have to remember this, because variables are the most used concept in any programming language. And to make things worse, the naming convention is different from language to language. If you try to learn naming conventions in Python and try to create another variable somewhere down in the future using the same conventions, it will fail. For example, these are the naming conventions in Python, right? In JavaScript, uh, names can start with dollars too. Dollars. But if you try to put a dollar in Python, it will complain. Yeah. Just remember that naming conventions differ from language to language. In our Python, we have four rules: capital A to capital Z, small a to small z, 0 to 9, and underscores, and cannot start with a number. That's it. And while you try to write the name too, always try to make the name in smaller case, because I will explain why later. Small and underscores. That's it. Don't try to use capital letters anywhere. Don't try to make something like this. This is quite tempting when you are first starting out with Python, but don't do this. Always write names with smaller case alphabets, and then underscores. Don't try to even use numbers unless it is absolutely necessary. Okay, fine. We even covered how to name a variable, what characters can a variable contain. And now let's understand what are reserved keywords. Let's say I ask you to write a poem, right? Something poem on something, anything. What you will, especially in English, I wanted you to write a poem in English. What you will do is, you might have already known few words in English vocabulary, and then put together to convey your meaning, right? You didn't invent the word. You know that a word exists and this word means something. So I am using it in my poem, or using it in my sentence, right? You didn't actually invent the word. Similarly, in Python, there are few words, few texts that already exist in the language that convey a meaning, convey a default meaning. We should adhere to that meaning. For example, true. True is a keyword in our Python, and false is also a keyword in our Python. And none is a keyword. You can just go over this. You need not remember them. Just go through them after the class ends. True, none, and why is this important? Because you cannot name your variable like an after a keyword. Let's say I wanted to create a variable name and holding some text, some string. See, it is complaining. Why? Because variable names cannot be the same as keyword. So as you progress in your Python journey, you will automatically know what are the key. There are, I think, 32 or so. You will automatically know that this is a keyword. If you are beginning it out, make sure that if you write a variable and it glows, that means that it is a keyword and you shouldn't use that. Let's say, is T a keyword? I think no. Yeah, okay. Wait. TR is keyword. Case is the keyword. Yeah, some see this is not going. Match, case, assert, raise. I think sometime it depends on our theme to ID theme to sometime it glows and sometime it doesn't glow. You need not worry because it is extremely rare that we run into the you name your variable exactly as a keyword and you will land this eventually. If you're interested, just go over it. Just remember that your variable name cannot be a keyword too. That's it. We have completed data types, data structures, variables, object referencing, variable naming rules, reserved keywords. Okay, good. Now, um, is everything clear or did anyone miss anything? Okay. Yeah, you can open your notebooks and try creating a new empty notebook and try creating variables, storing different data types and data structures. The main part, if you want to progress in programming as a developer, you have to run the code and fail again and again and try to read the error again and again. If you are not practicing anything, just reading and reading, this won't help you any further. You will just ignore it. Now let's go with functions and methods. Yeah. No. We will go into functions and methods detail in the later stages of the course, but uh, it is impossible to explain Python without knowing this. Here I am just giving a slight overview. Function or a method is nothing but a block of code. You need not know what Python code is written within it, but it will just accept data like data as data and then work on it and will return us back in another data. When I meant data, it can either take a data type or a data structure and it can return a data type or a data structure back. For example, let's say calculate mm, yeah. Let's say calculate employee score. Let's say we have a function called calculate employee score. You need not know how it is written. You only need to know what does it take as input. Let's say calculate employee score takes your name as an input, your employee ID as an input, and your perform no, not the performance, and your working days as the input. Like your performance from 0 to rank your performance from 0 to 100 and it will return back a number. When you are dealing with functions and methods, all you need to know is what will it take as an input and what will it give us an output. Sometimes functions will not return anything. In such cases, the return value will be none. The data that they take are called the arguments. Let's say, if there is a function, you should ask the question, what arguments will it take? How many arguments will it take? Or what type of arguments will it take? And if there is a function, you should also ask the question that what return value, return return value will it return? Will the return value be an integer, or will the return value be a float, or will the return value be a dictionary or a list, something like that? You need to know what inputs. Inputs is nothing but what arguments will it take? What output? Output is nothing but the return value will the function generate. In the later stages, you will learn how to write functions too. For now, just remember that functions take take data into it, process it, and return back a data output. You need to know what inputs will it take and what types of input will it take and what type of output will it return. And the name, word, function, and method are 90 most of the times identical. The only difference is, see here, I just created an function. This is just a code to create a function called double. This is the name of the function. And this def is a keyword, just like me telling Python that everything that comes after it is my function that I am creating, something like that. That's it. Def double. This is the name of the function. This can be anything. Here, the x you see is a variable or an argument, or sometimes called a parameter. And what this function is doing is return x star 2. Nothing but it is multiplying the x with 2 and returning this. Here you can see how a general function looks like. This part is the name. This part is called the input arguments. And this is the body. Body working on x and just returning back a value. Here, here I defined the function, right? Here number is equal to 5, nothing but a variable number holding the integer 5. Result. Here I am calling the function. Function is called using its name. Just we write down its name, open the parenthesis, and then give the input to it. Here this is only taking a single input, right? So I am just writing a single variable. You can even write this is much easier if I showed a function with multiple student average, maths, physics, chem. Here I am just creating a function called student average that takes in math marks, physics marks, and chemistry marks as input, and then we calculate an average. So how is average calculated? Sum by math plus physics plus chem by 3, right? By 3. I am just returning the value. Since the function is expected to return an average, this is called the definition, the name and argument it takes. This is called the returning, and this is called the body. Here the body is just a single line, but some cases it can span thousands and hundreds of lines. Now, when I run this cell, nothing will happen because I just created the function. I haven't invoked it anywhere. Here, now let me call the function. 22, 33, 444. Here, I am calling the function. Oh, sorry. I wrote the wrong student average. See, this function is taking these as input. These will be passed into these variables. This body will get executed, and the return value is returned back. The return value, you can directly use it, or you can store it in some other variable too. So, let's say you can store it in some other variable like this. Or if you want to see the value, let me print it. Let's say average. See, function. This is how a function looks. Its arguments look, its body look, and it returns. The difference between a function and a method is functions can be called directly using its name. We just call the name and write down its arguments, and it will be invoked. But in case of methods, Methods are dependent on an object. You cannot call a method directly. Methods will almost always look like this. Uh, you will learn more about methods later, but I'm just showing you how it is. Let's say there is a user called John Doe. I wanted to convert, this is lowercase string, right? I want to convert all of them into uppercase. In such case, user dot upper. See, the moment I put it the moment I have written a dot after the user variable name, the ID is automatically suggesting me the different methods that are available on this variable. This is asking me, this is showing various methods, but I'm just picking the upper method. See, the functions can be invoked directly. They do not need any objects. They take the data, work on the data, and given back. But the methods will only work on a variable or the data held by the variable. Here, the upper only showed up because the user is holding a string. But if the user is holding an integer, the upper won't show up. In fact, it will raise an error. See, it is telling me that the integer data type doesn't have an method called upper. The object has no attribute upper. See, methods are related to data types and data structures. You need not write a method. Methods are inbuilt. If you just place a dot after the data type or data structure, you will see all the methods defined on them automatically in your IDE. But functions are created. Functions can be custom created, or there are some functions that are inbuilt too. Let's say length. Length is an inbuilt function. Length can be used to find the length of any string or list or any other data type. See, here I am just calling the length function directly. I did not define it earlier. It already existed in the Python. I just gave it a string and it counted the number of elements in the string. And this is just an example. There are so many inbuilt functions and you will learn them in this course. Just remember that method needs an object. Method depends on object. If some methods are supported on some objects and not supported on another object. And functions do not need any object. We create them. If we give them the data they expect, they work on it and return us the results. And there are some custom functions we define ourselves, and there are some inbuilt functions that are built into the Python, and you can directly use them. Here, I listed down the some most useful inbuilt functions. Here, the type function. If you just write type and then give it any data, it will print. It will find out the type of the data. Here, let me write type and 22.22. We know that it is float, right? But type can help us as a kit. Now, this is a string. See, the type is string. This might seem trivial, but as we delve deeper and deeper into programming, this will become very important. See, here I just asked for what is the type of this list, and it told me this list. Type is one such function, and length is also used to find the length of strings, list declaration sets. Variable, you can go over the, you will understand. I think we have covered copy, used to copy the data and pass it instead of passing the address. And delete. Delete, you can ignore delete. You won't be using this much. And print. Print is the most useful function. If we want to know what the data inside a variable, all we need to do is write print, open brackets, and then let's say average. Write the variable name, and it will print it. You can even print multiple variables at once, or you can even write the data and it will print it directly. Here, see, here I am writing one variable, and from there on, I am just writing data and data structures directly into the print. See, print will take any number of arguments, any type of arguments, and will print the stuff. Here, everything we gave to print is printed. Print is generally used to know the data in a variables, and it is used mainly for the logging. if logging doesn't make sense, you will learn it in the later stages. What happens is we sometimes have thousands and thousands of lines of code, and when we are executing the code, a 1,000 line file or code, what happens is we need to know where the progression, right? Or which point did it reach, or how much is pending. In such cases, we write print statements to show to the user that progress has reached, executed 10 lines, executed 20 lines, and such. You have to remember type, length, and copy, and then print too. These are the most useful ones. Data type keywords. I just went over that there are integers, floats, complex, and stuff, right? But when you try to use the type function to know the type of the data, it results, see, it will return these keywords. It will return int, float, complex, string, and list, and tuple. This can be even used to convert one data type to another two. Let's say marks. Here the marks is a string, right? This looks like an integer, but this is actually a string. What if we wanted to convert this into an float number? All we need to do is write the float function name, then the variable name. And now let me try to check the type of marks again. See here, the marks variable originally held a string that looks like a number. And in the next line, what we did was we just converted the marks into a float and then tried to print the type. And it is showing me that it has been converted and the marks is now holding a float. Marks, comma, type marks. You might ask, will this work every time? No. Typecasting means converting one data type or data structure from one type to another type. Will only work if the data types agree. Here the number looks mostly, this string is mostly a number, right? So it will work. What if I put a and run it again? It will fail because this data cannot be converted into a float. Similarly, we can convert integer to floats too. This is an integer, right? We can convert integer to float. They will agree. Yeah. You can read the notes and see which type can be converted into another type and try running the snippets too. You will understand it a bit more. Here I have written down what type can be casted into another types too. The same applies for data structures too. There are some data structures can be converted from one data structure to another data structure too. And I have clearly listed everything in here. This typecasting is just a fancy name given to converting a data type from one type to another type. Data comparability, and this is important. Up until now, we have only created data, stored it in a variable, and used variables to print and to do basic math operations, right? What if we wanted to compare whether two data is identical or not? Let's say a user already signed up. Let's say new user on let's say admin is John. Admin has a name John, but you forgot whether what is the admin's name, and you wanted to compare whether the new user name is the same as the admin name. Then what will you do? You need a way to do it, right? This is done in Python using double equal to, or we call it comparison operator. Single equal to is called assignment operator, used to assign data to a variable. But double equal to is called comparison operator. It will compare whether the data is identical or not. There is a distinction between identical and same. You will, I will explain it later. New user is equal to old admin. See, it will return whether true. Okay. I didn't execute this. See, Here it is returning true because the new user John is the exactly the same as identical to old admin name John, right? Both are strings and both have same character. So it will return true. But if I wrote something else and try to run, it will return false. This is how we compare whether two data types or data structures are equal to one another. You can do this across any type and any structure. Here you can even compare whether this is equal to, this will be false because they are not equal to, right? You can even do this. You can mix and match any number of combinations. Here I am just checking whether the integer is equal to list, which is obviously false. Now let me compare whether a list is equal to list. 2.3.33. This will return true. See, here I'm checking whether one list is equal to another list, and it is giving me true since both are same. And now here is the crazy part. What if I do this? It is returning false, right? Why? I am just asking whether the first list is the same as the second list. And the above cell is stating me that yes, it is true, the first list is equal to the second list, but this is failing because it, comparison operator will only check whether the elements are identical. I mean, the data they hold is identical or not. It will not check whether both of them are the same exact data in the memory. Here, A is equal to 2, 2, B is equal to 2, 2. No, let me write A is equal to B. C is equal to again 2, 2, 3, 4. Int A equal to B. A is B. Int A equal to C. A is C. See, this is nothing but object referencing in its word. A is equal to this list. You understand this, right? The list is stored somewhere and the address is stored in A. Here, B is equal to A. You must understand that A is passing its address to B. So, A and B are pointing to the same data, 2, 3, 4. Here, C is equal to 2, 3, 4. This is creating a new list and then giving its address to C. So, when I try to check whether A equal to B, it will remain true because both of them are pointing to the same data, right? And when I'm checking A is B, it will also return true because equal to checks whether identical or not. Each checks whether they are the same entity or not, exact same location in the memory or not. So this is why the above print statement returns true and true because A is identical to B and A is the same as B. So we get true and true. But in case of the next line, A equal to C, A and C are identical. I mean, they look identical. But when I try to check A is C, it will return false because A and C are two different objects that look identically but stored differently on Python. Is the distinction between equal to comparison operator and is clear? Good. And this is the last time you will ever see is. You won't be seeing is again, but you need to know the difference between comparison and is. Is checks whether both the objects are same, the location is same, everything is same. But equal to checks whether they are their data looks identical or not. That's it. Data comparability, directives, variable comparison, optimizing execution. Yeah, that's it for today. If the time allows it, go through the these two notebooks, data and data types, and one dot data types advanced, and try creating few variables variables holding different types of data and data structures. If you find any section that is complicated, you can just ignore it. You need not remember it. Yes, we will. The complicated parts will we will encounter complicated parts again and again in Python. Like object referencing, right? There is an object referencing section in the previous notebook, but the same object referencing section will be discussed again multiple times. So if you find something very difficult to digest, just ignore it. We will be discussing it again in future classes. Yeah. Are there any doubts related to today's class? Okay, I am assuming everyone understood data types and data structures clearly, right? Yes.
Yeah, yes, Pawan.
Hmm.
Sorry, Tarun.
Yeah, fine. Thank you. That's it for today. You can leave.
Yeah, okay, Pawan. We'll meet tomorrow.